Hey, welcome to another junior geometry video. In this video, we're going to continue doing some geometric reasoning and look at a rule about angles in a triangle. Right, so here's what you need to know. Angles in a triangle sum up to 180 degrees. So the three interior inside angles in the triangle add up to 180 degrees. They always do. Every three angles in a triangle, no matter what triangle we draw, always add up to 180 degrees. Right, what else do you need to be aware of? You need to be aware that when we draw triangles called an isosceles triangle, where two sides are the same, then two angles are the same, and we often refer to them as the base angles. So we could say base angles in an isosceles triangle are equal. The two base angles are the same. The last thing to be mindful of is a triangle called an equilateral triangle. All angles are the same because all sides are the same, and they're each 60 degrees because 60 plus 60 plus 60 is 180 degrees. All right, let's show you very quickly what we've done here and talked about. So we've got a triangle. This is a scalene triangle. All sides are different and all angles are different, but it doesn't matter because all the angles inside that triangle will add up to 180. So that 49 plus the 74 plus that 57 will add up to 180. Now, it doesn't matter what kind of triangle I draw, this triangle, oops, that's the same in the reverse. So let's go to this triangle. We've got 101 degrees, 29 degrees, and 50 degrees. Those three angles are going to add up to 180, right? So whatever type of triangle we construct, the angles are always going to add up to 180 degrees, right? Now, even if we have a right angle in it, like that, this 90 degrees tucked in the corner, we still have the 58 and the 32 and the 90 degrees that would add up to 180 degrees. Right, now I'm going to try and, there we go, I've just drawn myself an isosceles triangle. An isosceles triangle is a triangle with the base angles are the same. So these 51s are all equal, the same. So I'm just going to add on two lines here to indicate that these two sides are the same and there are the base angles, they are the same. Right, so isosceles triangle, whatever type of isosceles triangle we draw, the base angles are the same. Now, I just saw for a moment there, when I get up to that point there, all three angles are 60, which means all three sides are going to be the same. So I'm going to just add in that line there to make it an equilateral triangle. And equilateral triangle has all three sides the same and all three angles at 60 degrees. So the key thing here, angles in a triangle add up to 180 degrees, right? Right, let's get back to our PowerPoint and do a couple of examples. So example one, we're going to determine the size of the missing angle. So we've got two angles given at the bottom. We're going to work out that top angle, angle ACB. Right, so angle ACB is equal to 73 degrees. How did I get that? I just took 180 because that's what the three angles in the triangle add up to, and I subtracted the 60 and the 47 that I've already got, and that left me with 73. Now remember, with all geometric reasoning problems, we can't just give an answer, we must give a reason. So our reason is angles in a triangle. You can say angles in a triangle add up to 180 if you want, but just angles in a triangle is fine. And our shortcut is angle sign in and draw a triangle. Right, example two, how are we going to determine the size of the missing angle? Well, we've only got one angle given, but we've got two dashes on two sides, which means it's an isosceles triangle. As soon as you realize it's isosceles, you know that the second angle at the bottom, the base angles are the same. So that's 51 degrees. And now we can do our trick by working out 180 minus 51 leaves us 78 degrees. Again, our reason is base angles in an isosceles triangle, and we can shorten it to base angles in isos triangle. Right, our last example, how do we work out the missing angle? Well, it's equilateral. So straight away we know it's 60 degrees, and our reasoning is angles in an equilateral triangle. Right, thanks so much for tuning in.